Hello friends, this is our last example of this topic, and it is determine the shear and moment in the beam shown as a function of x. We have to determine shear and moment as a function of x. As you all knows, for determining shear and momentum as a function of x, we have to find these support reactions first. So we will draw free body diagram of this whole beam first. So this is pin support here, this is pin support here. This will give two reactions, this will also give two reactions, but I will write only one reaction, that is vertical reaction, because there is no any horizontal force. So horizontal reaction will be 0 at this point and this point. So I will write vertical reaction only, that is, if this is point A, I will write vertical reaction at point A. Here is vertical reaction at point B, and this is a combination of two type of loads, that is, we can write it as a rectangular load and this triangular load, so that we can resolve it simply. In place of this rectangular load, I can write resultant load. For this, it is length into breadth, that is 9 into 10, it is 90 kilonewton, and this will be centroid of this will act at the centroid of this rectangle, that is 9 by 2 meter. So this will be 4.5 meter and this will be 4.5 meter. In place of this triangular load, I will write resultant load, that is area of this triangle. 1 by 2, base is 9 and altitude is 30. This will come 90 kilonewton, and it will act at the centroid of this triangle, that is 9 by 3 meter from the support B, that is 3 meter. So this will be 90 kilonewton, and this distance will be 9 by 3, that is 3 meter. Now in order to find this, first I will use this equation, summation of momentum at point A equals to 0, which further implies due to this force it is passing through the point, so momentum will be 0 due to this force, and due to this 90 kilonewton, it is minus 90 into distance 4.5. Just trying to rotate beam in downward direction, that is why I take this negative. Minus 90 due to this force into distances, total distance is 9 meters, so 9 minus 3, that is 6 meter away from the support A into 6. This is plus VB into distance is 9 meter, which is equal to 0, which further implies 9 VB equals to 4.5 into 90, 405 plus 540, which is 945 kilonewton. So vertical reaction at B will be 105 kilonewton. And now to find vertical reaction at A, I can write summation of vertical forces equals to 0, which further implies VA plus this VB minus 90 will be 0. VB is 105 kilonewton, so VA comes out to be 75 kilonewton. So I can write here this is 75 kilonewton and this is 105 kilonewton. Now I have to find this. I have to find momentum and shear force as a function of x. So I will choose any section. I will choose this section at a distance of x from the support A. So I draw this section. This section is from the support A at a distance of x, so I write this as x, and this is 10 kilonewton per meter. This reaction is 75 kilonewton. Now I have to find this force. So I can use this similarity. I can find this is 10 kilonewton here. I can find this by this property of similarity between two triangles. If two triangles will be similar, their ratio of their corresponding sides will be equal. So I can write here this is distance x divided by this distance, because these two triangles are similar. This distance is 9 meter divided by 9 equals to this distance. I will write it as y divided by this distance. This distance is 30 minus 10, that is 20, which further implies y comes out to be is 20x by 9. So this is 20x by 9. So this all will be 10 plus 20x by 9. So I can write for this is 20x by 9. This part is 20x by 9 and this is 10. Now we will first draw free body diagram for this section. Now I can draw free body diagram. I will write here 75 kilonewton, and this is a rectangular load. So I will write point load in place of this, that will be 10 into x, that will be 10x, and this distance will be x by 2. And instead of this triangular load, I will write a point load, that will be area of this triangle, which is x into 1 by 2 x into 1 by 2 area, that is x into this 20x by 9. 1 by 2 base into altitude, base is x. And here we are breaking this beam, so this will give 3 support reactions at this, but horizontal force is 0, so I write only 2 support reactions, only 2 reactions here, that is V and this momentum M. Now I can find easily. First I will use this equation, summation of momentum at this point. I will take this point as suppose point T. Summation of momentum at point T will be 0. So I can write 75 into distance is x, minus 10x into this distance is x by 2, minus this force, which is 10x square by 9, 10x square by 9. This is 10x square by 9, and distance is this x by 3 from the point T. This is x by 3 minus this momentum. This is also trying to rotate beam in downward direction. I will write minus m will be 0, which further implies m will be 75x minus 10x square by 2, that is 5x square, minus 10x cube by 27. So this is our momentum function. This is our momentum as a function of x. Now I have to find shear force as a function of x. For that we can write summation of vertical forces equals to 0. So I will write here summation of vertical forces equals to 0. So vertical forces are 1, 2, 3 and 4 vertical forces. So I can write 75. This is in upward direction. I will write 75 kilonewton minus this is in downward direction, minus 10x minus this force, this is 10x square by 9 minus 10x square by 9 and minus V, which is equal to 0. Summation of vertical forces equals to 0. From this V comes out to be 75 minus 10x minus 10 by 9 x square kilonewton. So this is a function, this is shear force as a function of x. So you can substitute the values of x as 1 meter, 2 meter, 3 meter, and you can find shear force at every point. Hope you understood this. Thanks. Have a nice day.